Hi everybody, we're going to find each limit or state that the limit doesn't exist and explain our reasoning if it does not exist. And basically this is our first one. And what I'm going to do is go ahead and break this up. You should kind of already know the limit rules. So I'm going to take the limit as n gets larger and larger here. I'm going to break this up and put the 5n under each piece here. So I can break this up as 7 over 5. I can write this as times 1 over n. And then this will be minus 2 over 5. Now, we already learned in the previous video, as this number, if I take this part right here, especially that part, the limit of 1 over n as n approaches infinity, or a huge number, equals 0. So what we have here is the limit of 7/5 times the limit as n approaches infinity of 1 over n minus the limit as n approaches infinity of 2 over 5. Now, this equals 0 here. And so the limit of a constant is just a constant times 0 minus, and this is a constant, 2 over 5. So this will be 0 minus 2 over 5, which equals negative 2/5. Okay. The next one is going to be the limit of n cubed minus 2 over n squared. Now I'm going to break this down and write it as, you can write this part here, just break it down, and this part here becomes just n. So what we're going to get is the limit Okay, so when I reduce this, it's going to be n minus 2 over n squared. And therefore, I'm going to write this as the limit of n minus 2n as n approaches a huge number. And what you can see is that for this part, this part is just going to be 0. However, for this part, if you get limit of 2 over n, we're going to get 2 times 1 over n, or you can put square there if you want. But what's going to happen, the limit of this is 0. So basically this whole thing's going to be 2 times 0, which is just 0. Alright? And then this part, you take the limit as n approaches infinity of n, that means this just goes without bound. So it approaches infinity and it becomes increasingly large. So this sequence has no limits, so it does not exist. Okay, the next one we have is the limit of 6n squared plus 5 over 3n squared. And I'm going to go ahead and we're going to put 3n squared under each piece. And we're finding the limit as n goes to infinity. So if I rewrite this and break it up, we're going to get 6 over 3 plus 5 over 3n squared. Alright, and then I'm going to further break it out as the limit as n approaches infinity over 6 over 3, which is 2, plus the limit as n approaches infinity over 5 over 3n squared. Now, we already know that this is going to go to 0, because this number down here is going to get increasingly large, the denominator. And however, this one, so that's going to be 0. This one's a constant, so anytime you're doing the limit to infinity of a constant, it equals 2. So we have 2 plus 0, which equals 2. Okay, the next one we have is the limit as n approaches infinity of 3n plus 4 times 1 minus n over n squared. Now this equals the limit of, and I'm going to go ahead and pull this out. You get negative 3n squared minus n plus 4 over n squared. And then I'm going to go ahead and put the n squared under each piece. So put this under each piece here and rewrite it as the limit of 3 minus 1 over n plus 4 over n squared as n approaches infinity. And basically, if you write it all out, you're going to get the limit as n approaches infinity of 3 minus the limit of 1 over n as n approaches infinity plus the limit of 4 over n squared as n approaches infinity. Now these two are going to be 0 because that's going to increase, that's going to get closer and closer to 0. So these are both 0. And the limit as n approaches a huge number of a constant is just a constant. So we're going to get 3 minus 0 plus 0, which equals 3. Okay? The next one, I think the next one I'm going to go ahead and do on a different video. So the next one we're going to go ahead and divide everything by n squared and deal with it that way. So that's all. Thank you and have a nice day. Bye-bye.